Hello, how are you? What's going on? Welcome back to another one of these videos from our little class. Sorry, I'm about like a week behind on posting. Just things came up, it got complicated. But anyway, what we talked about last week is we dove into, we dove into sampling a little bit more deeply. Apologies for the construction noises if you can hear those. We went a little bit more deeply into how to use play tilde and some of the other sampling objects to sample audio directly from a buffer instead of using the playlist tilde object directly. Major reasons you would do this: number one, you got a lot more control, low-level, granular sort of control over how playback is handled. And we'll see kind of what you can do with that in a second. Number one. Number two, you can't use playlist tilde with Rainbow. So in Rainbow, playlist tilde is not supported. There's a lot of higher level, more complicated sort of, objects like that aren't supported in Rainbow. But in general, if you're using the lower level, more direct objects, there tends to be pretty good support, at least as long as you're in the audio and max domain. So let's get into it. Play tilde, what does it do? Well, actually, let me save this. Let's make a little place called in class OTI. That's the convention we're using here. Call this P01 C06. Okay, so what do you do with this play tilde object? Well, the basic idea is you create a buffer. And a buffer is just a block of space in Max's application memory that holds onto your audio file. And then through a bunch of objects that interface with that buffer, you can do whatever you want in terms of getting samples from that buffer and playing them back. So if, for example, we make a buffer here and call it sample1, a really original name like this, then to replace the contents of this buffer, you can send it the replace message. And if we do this and then grab one of our cute sound studio samples, grab one of our files, for example, this loop. If I double click on the buffer, then you can see that it's loaded up the audio samples that were in that file. You can also just take any one of those sound files. So for example, if I grab a different one like this one and just drop it onto the buffer, now that's loaded instead. If you want to look at the contents of this buffer at any time without having to double click on it, one easy way to do it is with the waveform tilde object. It's an interface, a UI interface to the contents of the buffer. So you could do waveform tilde at buffer name sample1. And that binds this waveform tilde to this buffer. You could also come into the inspector here and go with the waveform tilde selected. You could come into the inspector, go down to, where is it? Here, buffer name, and you could swap in, or you could type in rather the name of that buffer. And if you set this to a different buffer, so for example, if I had another buffer here called sample2, and now there's nothing loaded into it, but if I drop a different file into there, and then I send this waveform tilde the message set sample2, you can have this waveform tilde jump between either showing you what's in the first buffer or the second buffer. To actually play back the contents of this buffer, we can now use a bunch of objects, among them play tilde. And the way play tilde works, in general, all these sort of interface to a buffer objects, they work, they all kind of fetch samples from the buffer, but they fetch them using a different kind of interface. So with play tilde, it's a millisecond interface. If I send this an input like line tilde, and I say to line tilde, okay, start at 0, and then ramp up to 1000 over the course of 1000 milliseconds. This makes a straight line that goes from 0 to 1000 in 1000 milliseconds. So in other words, if I connect this to play and do something like this, we'll hear the contents of that buffer play. How did I get so far from the top left corner? We'll hear the contents of this buffer played back at normal speed. At least we should. So there's the first second of that buffer played back at normal speed. If I wanted to play it back twice as fast, I could cover the same distance. So the first parameter here, 1000, this is, remember, this is where the line is going to. And so this is how far into the audio file we're going to go. So I could go twice as far in the same amount of time. And now we're playing the first 2 seconds of the audio file in 1,000 milliseconds. So we're going at double speed in a sense because we're playing a second's worth of audio, 2 seconds worth of audio in a single second. So you could call this one first, second, normal speed. We could call this first 2 seconds, double speed. We could, of course, play half speed by saying, let's play the first second, but let's take 2 seconds to do it. And it's also kind of useful, probably, or it could be useful here to, you can use the line message to waveform tilde to draw a line over the audio file, which is nice for visualizing things like what play is doing. I can do snapshot here to grab a picture, a message rate. Remember, snapshot converts from audio rate to message rate by, in this case, taking a picture, a snapshot of the audio waveform every 16 milliseconds. And if I do something like line, I choose 16 milliseconds because that's 60 frames a second, even though Max only refreshes at 30 frames a second, so I don't know why I do that. But anyway, here's what that looks like. So you actually can get a nice visualization of what's happening. And lastly, you can also, of course, with play tilde, play backwards. So this is first, second, half speed. And you could play backwards easily, too, by saying, OK, let's jump to us 1 second in and then come back to time 0 over the course of 1,000 milliseconds. And this is just going to play the first second backwards. So play tilde is really cool in this case because it gives us this very direct access to the contents of this buffer, and we can index into it using line and play in this very kind of normal way, air quotes normal, like constant speed. We have a lot of flexibility too. So let's just save this now, P2. So instead of using line, we could just index into the buffer directly, or into play tilde directly. I could make a slider. And I could change the length of this slider to be as long as our buffer is. So right now, just looking in the inspector here, I can see these default values for a slider, float output off, and range, just 128. I'm going to turn on float output, and then I'm going to use an object called info tilde with sample 1 here. And info tilde lets us fetch information about the buffer. So in particular, if I grab the 4th outlet from the right here, and I always forget which one it is, but you can hover over these, of course, to see what these different pieces of info are. When I send this a bang, it will go into the sample 1, info for sample 1, and look at how long it is and send that out at its second output here. If I make a message like size $1, and connect this to this slider and hit this bang, now we'll see the size of this buffer, or this slider, its range is 4800. And if I connect something to the output of the slider and drag this around, indeed those numbers are what come out. So it's tempting to just take this and connect it directly to play tilde, to pass this into a sig, to convert this number to a signal, and then connect it to play. And it kind of looks like, especially if I make a through object here, through is kind of handy sometimes. Through doesn't do anything, but it can be useful if you want to patch route a bunch of cords. It's like a cable tie, essentially. You can just bundle a bunch of stuff together before it goes out. So if I now look at what's coming out of this, we hear this like really unpleasant crackling sound. And looking down here, it's kind of surprising. Like it looks like we're scrubbing through this audio file sort of as we would expect, and yet it doesn't actually sound right. Well, if I take the output of this sig and divide by 4800 so that we can see a little bit better, just to take its range and make it 0 to 1 just for demonstration purposes. If I do this and then make a live.scope, we can get a better sense of what's going on here. So as I drag this around, especially if I drag it quickly, you'll notice a lot of jagged edges here. And that's because, of course, this is that, especially if I jump around like this, it's that old problem with zipper noise. So this, as I drag the slider around, it's sampling. The application is sampling the position of the mouse, maybe at its fastest 100 times a second or so. But of course, we're playing back. The audio engine right now is running probably at 44.1 kilohertz or maybe 48 kilohertz. So it needs a lot more samples than that every single second in order to make a continuous audio waveform. So we use the snapshot here to downsample from audio rate to message rate. To upsample, you can go straight through SIG like this, but oftentimes you'll want to have some kind of interpolation or smoothing between these kind of jagged relative to audio rate signals data coming from the slider. So one way to do that is just to make a line object. I think we saw this in a previous class when we talked about zipper noise, and I can just do $140 like this to upsample this message to be nice and audio rate, like so. And if I connect that here and here, get rid of this SIG, you'll see as I jump around, things are a lot smoother. And as I scrub forward, you can hear that we're able to audition what's going on in the sound file a little bit better, although, you know, without going too deep into how to build a better scrubber, it's not quite as clean as you might expect if you work with some kind of application that lets you preview audio files by scrubbing through the audio file. But in any case, you could even imagine, like if I hook up a Metro here, and I just do something like, let's do 500 and then random, 4800, and then $1 500. You could imagine using something like this to build a kind of some kind of crazy noise-making tool. It's a little bit glitchy. We could do, maybe better would be drunk, which is like random, but it can only go so far in a given unit of time. So we could try something like this. I wonder how this would sound. So because of the way I've set up this drunk object, it can only move back or forth up to 250 milliseconds, and so this thing is sort of limited to playing, because of the way this line is set up here, chunks of audio either anywhere between not playing them at all, being totally stopped, and going up to double speed. So anyway, you could kind of use a system like this to mess around a little bit and maybe make some kind of weird noisemaker. So the other thing that I should mention about using play tilde is that because we are dealing with audio to index our position to this play tilde, we really have a lot of freedom with respect to what kind of signals we use in order to address the input of this sample. We're using straight lines here, and that gives us audio playback at a constant speed, but we're by no means obligated to do so. I'm going to get rid of all this and just show what I'm talking about. So this is using line, but we don't have to use line. We could use any kind of arbitrary function. There's an object in Max called function that is basically a line editor for line tilde, and as we'll see in a second, curve tilde objects. So if instead of sending these simple messages to line, I use this second outlet of function, I can build, just by locking, clicking, and dragging, kind of arbitrarily complex waveforms. And then when you bang this, it kind of sends it all to line to execute. The only reason it's not quite working the way we want is because the second argument to line here is going to be is not scaled correctly. So this function object, in its default configuration, the y values only go between 0 and 1. Of course, this audio file is between 0 and 4800. So what I can do is take the output of this guy here and send messages to function here to format it correctly. So we'll send it a message like clear, range, $1, domain, $1. And if you do something like this, now when we click and make these points in our function object, we're kind of the distance that we're going in each direction is proportional to the actual length of the audio file. So we could make really complicated little things here if we wanted to kind of shape the journey, I guess, of our playhead through this audio file. And there's some interesting sound design possibilities there, especially when you combine this with curve mode. So if I change this line object from a line to a curve, now we can draw not only straight lines that have a constant sort of speed to them, a constant slope, because it's the slope of the line that determines the speed. We can actually make curves whose slope is changing continuously over time. And as from a sound design point of view, this is where things start to get really interesting. So in order to make function tilde work with curve, you have to come into the inspector and find this mode attribute and change that from linear to curve. Now I can actually draw lines in here as usual, but if I hold down Option, I can change the curvature, either convex or concave, of this line. If I hit this bang now, you can hear the speed of that change, or the speed of that playhead change, I guess, changing over time, which, as you can hear, lets us make some kind of funky sounds. Hold Shift to delete these, and then just we can go like this and this, and yeah, make some kind of interesting stuff. So with this and a couple more little tweaks, we can make kind of an interesting sampling tool. We haven't really looked at the preset object yet, but preset is one of a handful of ways to kind of save the state of different objects in your patch. Not all objects are compatible with preset, but many of them are. Many of them are, in particular, UI objects are almost always compatible in one way or another with preset. So this second outlet, you connect to objects you want to include. There's kind of a few different ways you can make preset work. Check the help file for a full disclosure, I guess, of what those things are. But if I take this first outlet rather of preset and start to connect it to things, those are objects that are included in the preset definitions, I guess, that I can store here. So right now this is empty, but if I hold Shift and click on one of these, now this curve is stored in the first preset here. And if I clear this and make a different curve, something like this maybe, and then I shift click here, now this first curve is in preset 1, the second curve is in preset 2. And let's just listen to a few of these. It's a little too long, let's make it a bit shorter. So there's one, here's one, here's two. Way too long. Let's make that shorter. I'll store that. Let's make another one. So maybe something. I'm just kind of messing around. Let's try this. Maybe somewhat from a different part of the file. Go a little shorter. That's good. I'm trying to make a few kind of short little one-shots just to have something to play around with. I like that. Let's move this around somewhat, maybe here and here. Oh, that's really good. I'm into that. Okay, so what we can do now is we can make this into a kind of little sampler for ourselves. So if I put an integer box here and then TBI, I can recall a preset using this number and then bang on the function to kind of like send it out. So I can actually kind of scrub through these presets by going like this. And this gives us a way to, you could obviously combine this with key up, key down to make a kind of finger drummer. You could also connect this to another application. So for example, if I open up Live, and I really hope this doesn't mess up my audio, I'll have to look in OBS quickly and make sure this isn't messing up the audio. I'm going to be livid if it does. So let me see. That looks okay still. Desktop audio is kind of peaking, but that makes sense. So if I come to a MIDI track here and I send the MIDI to Max 1, now in Max, of course, I can make a note in, and if I set this to, actually, since it's on all devices, it'll get MIDI from any device, but in particular, I could narrow it down to 2 Max 1, and then in Live, I could come in here, draw an audio, a MIDI clip rather, something like, something like this. For now, just to make sure something is coming in, hit play. So those, and I can see in Live that those MIDI events are going out. In Max, if I put a message box here, cool, there's my pitches. So we could throw in a strip note to get only the note ons, and then maybe subtract 59 so that 60 becomes 1, 61 becomes 2, etc. And now I can sort of make a sequencer in Live. So it's all 1 because it's that's what I drew in my clip here is just C3. But if I do something like this, something like this, now we can see those numbers coming here into Max. And if I connect this to this guy, and now I can use Live to sample Max. Yeah, so you could imagine using this to actually make a kind of like quite a cool, I think, instrument or sequencer that you design kind of with a combination of Max and Live. Max to draw these curves, and then Live to make your sequencer. Of course, the nice thing about this is you drop some samples or some other sequences into Live, and if you use Live's transport like this, then everything is synchronized in one place. The kind of clock or the tempo or whatever that you establish in Live, Max is going to follow that because it's basically just being used as an instrument for whatever's happening in Live. So I want to show now, this is one kind of approach to driving play, not just with lines, but with curves for sort of a sound design purpose. But you can also use it kind of in a more continuous way, I guess, in order, to build up some kind of textures. So what I mean by that, as I get rid of all of this, suppose instead of using a curve or a line with play like that, we just addressed it directly using a phaser object. We haven't really used phaser that much yet, but phaser is really useful because it kind of makes, or what it literally does is make a bunch of ramps right next to each other. So if I go like this, phaser 1 into a live.scope, you can see that it's making these ramps from 0 to 1 over and over again. And this is really useful for doing things like driving processes that repeat in some way. I could take the output of this thing in particular, and if I multiply it by 1,000 using multiply tilde to work on signals, now I've got something that's playing the first second of this audio file over and over again. So this is, of course, just using this, this straight line, but I could index into this in another way. In particular, I could take the output of this, and then instead of using a straight line, I could go back and forth using some kind of sinusoid. So I could do something like or actually, yeah, maybe the way to do this is with a cycle 1, and if I scale the output of this to be, instead of in the range -1 to 1, the default output for scale, and I go in the range 0 to 1, now this cycle is going, if I do live.scope, you'll see the output of this cycle is between 0 and 1, just like the output of this phasor is between 0 and 1. And that's useful because now instead of plugging this phasor into this times tilde 1000, I can plug in this cycle. And we can listen to what this sounds like. You almost have this like record scratch sort of effect, especially at the boundaries where we switch from going forwards to backwards. And you can, crank the speed of this cycle and start to cross that like rhythmic timbral threshold. At this speed, it's pure timbre. You can't really hear this going back and forth at 134 times a second. And also you could use something like a range slider, R slider, and let's make the range of this, let's change this to be 0 to 4800. And instead of doing a times tilde here, we could use a scale tilde, 0, 1, and make it 4800, and set the lower and upper bounds of this R slider, or that we're going to scrub over, using this scale. So instead of this, we could go like this. And now it's scrubbing the whole audio file, but I could pick just a little chunk. Got a little timbral manipulation tool here. I'll also just show quickly that in addition to using a cycle for this, one kind of cool trick I think is you can take a phasor and we could just do like greater than tilde 0.5 to turn this phasor from a ramp into a true square wave. So it's either 1 or 0. 1 wherever the value is greater than 0.5. Actually, it might be a little bit. This doesn't really matter. 1 when it's less than 0.5 and 0 when it's greater than 0.5 to make it into a true kind of square wave. This is jumping between two values, so of course we wouldn't actually hear the difference, but you can take a low-pass filter. We could just do like low-res, maybe 10, 0.9, and this adds a kind of smoothing. Let's do 0.99. Yeah, you can see I've added a little bit of smoothing to this thing. I wonder if I go 5, was this even? Yeah, even more smoothing. You can really start to manipulate. It takes a little time for it to get up to 1 or back down to 0. And this is also kind of an interesting thing to sort of drive this playhead with, especially from a timbral perspective. Oops, I connected the wrong thing. I meant to connect this. Hold on a second. I have to connect this here. You can hear it sounds a lot different from that cycle. And you could, of course, well, and while we're here, I'll make a selector. Selector you can use to choose among a bunch of different audio inputs. So what I'll do is I'll connect the phasor, the cycle, and this other kind of guy all to the same scale. And then I'll pass this into this like so. So we can now scrub around this or kind of like sample this audio file using 3 different waveforms. And I'll make here, let's make what's the best way to do this? Because we're picking between 3 things, not 2 things. So instead of using a toggle, maybe we want to use a radio group. Radio group is such a weird object though. Okay, whatever, we'll use radio group. Radio group, give it 3 items, 3, and then +1. And this lets us choose between either a phaser, sounds like this, and maybe we'll connect them all to the same speed as well. So right here you have this thing here letting you control the speed, this letting you control which one of these 3 waveforms you're using, and this R slider here giving you control over which part of the audio file you're playing with. All of these could be connected to a preset, to some kind of system that's going to drive these things with a sequencer, and very, very quickly you can get to a kind of musical process. Maybe we'll I was going to say maybe we'll try it, but I'll leave that as an exercise to the reader. Feel free to play around with that and see what you come up with. So one more thing that I want to show before we so this was a shorter class because we had a guest speaker come in and talk a bit about their work. But one thing that I want to show going back to this, actually, let me bring up again this example because I kind of forgot about this and I'm going a bit out of order here. But these curve points in the function object, you can control these using the mouse by clicking and creating them like I showed before, but you can also create them using messages. So if I send a message like 1, 1000, 1000, 0.5, this is take the first point, move it to the position 1000, 1000, and give it a curve 0.5. And I can do the same thing with with the point 2. I can say move that to point 2000, 2000, and give it a curve 0.5. Oops, 2. This didn't work. I guess this needs to be 0, and this needs to be 1. Is that what this is? Yeah, okay, cool. Maybe this should be like this. I had a bit of trouble getting this to work in class too, if I'm being honest. So it's possible that I don't actually understand how this object works. Maybe it's got to go to 3000, 3000. 1, 0. Maybe they got to go together as a list. I don't know. So there's something I got to check the help file for this object to remember how it works. It's funny, in class I was like, man, I can't get this to work right. I'm sure when I record this video, I'll get it to work. The only reason I want to show this is because this lets you, this is an interface to kind of change these curves programmatically as opposed to using the mouse and keyboard. And that opens up some, I think, kind of fun sound design possibilities. In particular, one thing you could do is you could say, take everyone's, I'm just trying to find the sound, the patcher that shows this, not this one, but this one, no, maybe this one. Yeah, so I've got my trusty game controller here, and one thing that this lets you do, why is this not working now? Because I got to put an audio file in here. So I'm going to drop in an audio file like this one. And now you can see that I'm moving the 2 joysticks around and creating a kind of curve by moving these around and then using the shoulder buttons to change the curve. And I think, yeah, so using the 2 shoulder buttons to set the curve and the 2 shoulder triggers to play the sample. you could make your own kind of sampler. So this is also in the repository. Feel free to have a look. But really, it's doing the same thing as we did before, using a curve to drive a play, but where you can control the start and end points of the curve and the curvature of the curve using the gamepad controller. Okay, so the last thing I want to show before we wrap up is one more way to sample a buffer, and that's using the wave tilde object. So play tilde, like I said before, play tilde, wave, index, groove, they're all different ways of getting access to the samples of a buffer with a different interface. With play tilde, the input to the interface to the buffer is millisecond position. With wave tilde, it's just a number between 0 and 1. So 0.5 would be give me the halfway point of the buffer, 1 would be give me the end of the buffer, and 0 would mean give me the beginning of the buffer. Any number in between 0 and 1 gives you a different position in the buffer. This can be really useful when you're dealing with buffers that are all kind of different lengths, and I'll show you what I mean by that. So supposing we had, I'm going to save this as patcher 5. Suppose we had a buffer, called cycle 1. And into this, I'm going to load. So what you can do is, suppose we had a sample like, let me see, I think in class 3, yeah, we made this recording. Hang on. We made this recording in class 3. Is Audacity going to open? Yes. Okay, so we made this recording in class 3. This recording in class 3. And one thing you can do is zoom in on this guy, and you can see that this thing is sort of composed of these different, like in this piece, you can see a sort of repeating chunk. It looks like a little M. There's a repeating chunk here that kind of looks like a little cat to me. Like, do you see it? Like right here. This is, well, as I zoom in, yeah, see, this is the tail. These are the ears. That could be a little cat, right? So anyway, these waveforms you can kind of grab as little chunks representing the timbre, like a snapshot of the timbre of the sound at any one point. And if you loop them, you can kind of grab onto that timbre and hold on to it. So you could come into this sound and just grab one of these little M's like this, and I could do export audio and call this cycle A, and let's put this in our folder. So we're in class OTI in class 6. Cool. And then I'll also go over here to these little cats, and I'll grab just one of these and export audio. We'll call this cycle B. And back in Max now, I can make two buffers to hold my two different cycles. And I'll throw in a waveform at buffer name cycle 1 and a waveform at buffer name cycle 2. So this is linked to this buffer. This is linked to this buffer. And now I can drop in my little cycles. So we just made these two cycles. They're in class OTI, cycle A, cycle B. So there's cycle A, there's cycle B. As you can sort of see from the jaggedness of these waveforms, these are very, very short pieces of audio. But if I take one of these and I index into it using wave tilde, so if I take wave tilde and phasor, which remember goes between 0 and 1, and give it arguments like, I don't know, 50. That'd be kind of low frequency, but let's listen to it. We should be able to, live.gain, just being a little careful in case it's very loud. Easy DAC, and let's just bring it up slowly. Wave tilde, I'll call this cycle 1, so it listens to this guy, and let's see if we can hear anything. Sounds like somebody with a very deep voice, hopefully. If I bring this up, starting to sound a little bit more like my my voice, my timbre. And a little bit like somebody making an L sound, which makes sense because it's from the portion of me saying the word hello. I could grab another wave here, cycle 2, make another, maybe we'll even use the same phaser, but let's listen to this one instead. So you can hear again, we've got like a little snapshot of just that particular timbre of the sound. And I could, of course, make a slider and come in here, change it to be a floating output in the range 0 to 1, and then make a line tilde for smooth, to smooth out the signal coming, or the messages coming out of this, to upsample them to be a signal. And I could change, I could send a message to this like $140. And now if I want the, what I'm trying to do is make a crossfader that fades between these two waves using this slider to say all the way on the left, give me wave 1, all the way on the right, give me wave 2. So to do that, I'll take the output of this line and I'll say, okay, when this line is 0, this thing should be multiplied by 1. When this line is 1, all the way on the right, this one should be multiplied by 1. And that's pretty easy to do. I can just use a scale 0, 1, 1, 0, scale 0, 1, 1, 0, and scale 0, 1, 0, 1. It's kind of redundant because the scale on the right isn't doing anything, but for maximum clarity, you take this guy and multiply it by this, and you take this guy and multiply it by this, and now we've got an extremely simple crossfader between these two pieces of audio. You can maybe kind of hear that in the middle, it's not quite as loud as it is at the extremes. You can even see, if you look in the live gain, that it's louder at the extremes. That's because if you take two decorrelated waveforms and make them give them half their amplitude and add them together, the amplitude of the resulting signal won't be as loud as if you had just made one of them half as loud, because gave one of them half the amplitude, because of the waveforms interfere, because they're decorrelated. So in general, we don't crossfade signals like this. We usually use an equal power crossfade, and there's a couple ways to do this, but a quick and dirty way. I'm skipping over a bunch of math here, but long story short, with these, generally instead of using the 0 to 1 value here, we would use the square root of the signal. It just pulls it up closer to 1 and rounds out this curve a little bit. So if you look at, let's see, live.scope to look at this. So here's me just ramping the signal from 0 to 1. It's kind of hard to, I'm trying to give a way to show this more cleanly. The way to show this cleanly is to use, if I use a phaser here and connect it directly like this, you'll see it's this very straight line curve. If I connect this through a square root, you'll see it's like, it curves up. It's got a sort of gentler knee to it, and that will make the midpoint of this crossfade a little closer to kind of a equal power crossfade, to where it'll sound equally loud throughout this whole fade from the left to the right. Let's see if it works. Okay, a little bit closer to what we're looking for. If you come back out to the prepared patchers for today and go to, I don't know which one of them. Is it this one? No, is it this one? Yeah, you can hear the same thing, but scaled up a little bit to actually work with 4, crossfading between 4 samples at the same time, which can be interesting too. there's a lot of possibility there for some interesting sound design. If you were in Live and you happen to have a version of Live that had wavetable, this wavetable object, you can see that if you played with this. As I go between these different waveforms here, and you hear those different timbres, it's doing literally the same thing. It's got a bunch of wavetables, which is what these are called. It's why the object is called wave too. These short little pieces of audio, and it's just crossfading between them. I mean, it's doing them in a fancier way than we're doing here, in a more efficient way than we're doing here. But that's kind of the essence of a big part of how that instrument works. Okay, so there's some ideas for how you can use play tilde and wave tilde for more creative sampling. Hope that was interesting and useful. And yeah, let me know if you have any questions, and I will see you guys whenever I record the next one of these, which might even be today, but will probably be tomorrow. But in any case, thanks for watching and take care. I'll see you around.